Okay, sorry about that. So the recording starts now. I'm sorry, I forgot to turn it on earlier. So anyway, let me just recap slightly here. And by the way, if you have any questions, just unmute yourself and talk anytime. Okay, so the background is least squares, and we are trying to reformulate our least squares linear regression example as a matrix product. Okay, so here's the theoretical model, a plus bx1. Alternatively, you can write it as 1 times a plus b times x1. And the second theoretical value is 1 times a plus x2 times b, and so on. So you successfully separate the unknowns, there are just a few things usually, a and b, from this matrix A. Similarly, for a quadratic model, you can separate that as follows. Okay. And how do you make the theoretical values fit the experimental outcome y, the data vector, as much as possible? Okay. So all these three things are saying the exact same thing. Okay. Make the difference vector as small as possible, but what do you mean a vector is small? Okay, of course that means its magnitude is small, okay, or magnitude squared. Or you can look at this, which is original interpretation of making this line fit all these data points as closely as possible. So how do we do that? Well, I'm going to make a very long story short. I will just give you the answer, which is proven in many linear algebra courses, and maybe you've had that. Of course, the answer depends on what's in A and what's in the data vector Y. Of course, the X data is contained in A. So it's A transpose times A. That matrix is squared, so you can invert it, multiply to A transpose Y. Okay. You can verify that this formula would give you the same long-winded formulas in linear regression. But this allows us to treat more variety of problems. So if you want, here's a link in our math department. There's a fantastic set of lectures given by Professor Chesnov, and you can see his proof for this formula. I'm just going to use it. Okay. So let's see this application here. Suppose we have x and y data again. But after a scatter diagram, we decided that this is a better model. Okay, so we go a little bit beyond linear regression now. Let's suppose we want quadratic, although it can also be done easily on your calculator by some functions in the menu. Let's do it with a full transparency. So x data, I will put it in vector called x. Y data, I'm going to put it in my y vector. If you want to find out what is A, you can just refer to the previous page. Okay, now let me have both items appear on the screen. Now please get your calculator ready. Okay, we're going to do this together. Or if you like to just watch the process, and you can try it later. So first of all, let me input all my X data. So of course I insert a new document, put in a calculator, okay, and let me just, okay, let me expand the screen a bit here. X is going to be a vector, so control on the template key to get you colon equal, and open a set of curly brackets, which is on top of this key. So control and close parentheses. And I'll just put in my values separated by commas, 1, 6, so on. Okay, so that's my X vector. And my Y vector similarly will be colon equal to, open parentheses, sorry, open your curly bracket, And let me just put in all these numbers here. Okay. Just double check all your numbers because as they say, garbage in, garbage out. Now you can check that these have indeed gone into these two variables by inserting a spreadsheet. Okay, you don't have to do the step, but let's just give it a try. If you insert a spreadsheet as a second page to this problem, and go ahead and enter X in the column heading, then you will see that set of numbers pop up again. If you go to B column and enter Y as the column heading, then you will see your Y vector, Y values. Okay, let's just go back to my calculator here. Now let's think about what we need to do next. Okay, we want to, okay, let me just remind you what we want to do. We want to implement this formula. Okay, I have X, I have Y, and I can build matrix A using my X values. So it's going to be this particular matrix that I need to carry out my least squares analysis and find the answers. What are the answers? A, B, and C. Okay, the best coefficients for my quadratic model. I notice first of all there's a whole column of ones and a whole column of x's and a bunch of x squared values. So let me think about how to generate that easily. So first I want you to learn a little bit more about handling matrices. Okay, let's say we have two lists. Okay, let's say R1 is 1 comma 2. R2 is 3 comma 4. How can I put or stack these two rows of numbers together to form a matrix like this? 1, 2 on top of 3, 4 as the second column. There's an easy way to do this. If you open another set of curly brackets and put in just R1, R2. So what is this? This is a list of lists. Of course, I made a mistake here. Okay, what was done here was nothing much, okay? Because a colon means two separate commands entered in one line. So I should have put in an equal sign here. Colon equal does only one thing, okay? It assigns the right-hand side to the left-hand side variable. So having done that correctly, then you can go ahead and do what I just told you to do. Open curly brackets and put in R1, comma, R2. This is a, technically speaking, a list of two lists, and that gives you a matrix, okay? Those of you in computer science probably know that. A list of lists is a matrix. So I just hit my microphone. I hope it's still working. Okay. At any point, if there's any problem, just let me know, okay? So by the same token, I'm going to make it easy for myself to construct my A. In fact, let me do A transpose first. Why do I do that? Let's take a look at A first. Well, what is A transpose? Because I need that also, right? So I have one, I have the other. So A transpose is a fat and short matrix, okay, which has all the x squared values on top and x values in the middle column and just a bunch of ones. Sorry, I should have said in the middle row, okay, because I'm talking about A transpose here, okay, and a bunch of ones as the last row, okay. So this allows me to apply the idea that I just introduced. If I can create a list of 3 lists, this is list 1, this is list 2, this is list 3. Okay, so I just need those to assemble my A matrix very quickly. Okay, so this is how you can do it. So first I need those bunch of ones. I'm gonna call them what O. Okay, that's colon equal to. Okay, let me also introduce you to another command called sequence. Just press this book key, S, and you can control 3 to scroll down quickly, and you see a sequence command. So first, you tell it what you want to generate as an expression, usually a function of the index variable and the low and high values. Okay, in this case, it's quite easy. It's just a constant function, comma, and the index, we can call it whatever we like. We can call it kk or n, doesn't matter. Okay, which goes from 1 to 5 because I want to generate 5 ones. So that's an easy way to do it. Okay, and let's not forget I called my x values x. Okay, what about x squared values? Well, that you can easily do by literally just squaring that list. It knows what you want to do. Okay, so here are the things that I need to form the individual rows of A transpose. So let me just form my A transpose now. A transpose will be curly brackets. Remember, the top row has the squared values, so it's x squared. And the second row, in fact, this method works for more than 2 rows. You can have 3, 4, any number of rows. So the second row is going to be my x values. And the third row is going to be a bunch of ones. So here's very efficiently how you can generate the A transpose matrix. And of course, now you have the A matrix. It is just the transpose of A transpose. Then you get A back. Where's the transposition key? Again, press this book key and press T. That's the very first command that you get, the transposition command. Okay, so there's your A. All right, so now that we have A transpose, we have Y, we are ready to compute our solution in the easiest possible way. Okay, now just a slight technical note here. Can you do it right away? Okay, let's try it. A transpose times A, and whole thing is inverted, so raised to the -1 power. And okay, use the arrow key to come out of this exponentiation. Multiply to A transpose times Y. That's the formula, if I remember correctly. Let's just take a look. Okay, so that is the formula that I want to implement here. A transpose A inverted times A transpose Y. But it's not going to work like this, okay? Because some of these things are not of the same kind. Namely, Y here is a list. It's not a matrix. So if you press enter here, it says an argument is of the wrong data type. It's this Y here, okay? So we need to do a little bit more. Y vector, okay? Just a little bit of extra work. Y vector is going to be the list Y converted into matrix, actually a vector, okay? So there's such a command, okay? So let me explain again. Because Y is a list, not a matrix, not a vector, we need to convert it. So to convert a list to a matrix, we need to use this command, convert list to matrix, okay? Namely, well, this converts it into a row vector. We are just one step short of what we need. So it is to be transposed again, okay, to turn it into a column vector. So you need a transposition command again. So that will do it. That will do the trick. Here is all the y values as a column vector. Now we are ready. So let's go back and just copy that, okay? And just change y to yc, okay? It's a y vector, okay? So there's your answer, okay? Maybe you didn't wake up yet. Now it's time to wake up, okay? It is the best answers to A, B, and C. There's your quadratic model. Okay, let's see what time it is. It's 11:30. We still got 20 minutes, okay? So we can talk about a lot of things. So these are what your other professors may ask you to go through a lot of hand calculations to multiply the matrices and invert the result and do more matrix algebra in order to get. But here you see how easy it is, okay? Well, we have a lot of time, so actually why don't we actually take a look at the data. So here's something extra, okay? Let me go to the menu here. Sorry, the menu is here. Statistics, stat calcs. Can I do quadratic regression? The answer is yes. You can do it automatically. The X list is just X. The Y list is just Y. Okay. So you see three numbers, okay? You bet that these are the same, okay, as what I got with my matrix method, okay? And in fact, R squared is so close to 100% that I know this is a very good model. Let's also do a, sorry, I should go to menu. I'm just trying to repeat all the calculations for a linear model, okay? So again, just X and Y. You see, it's still also very good. It's also very good, but not as good as the quadratic model. Okay, oh, sorry. Somehow the output didn't come out. Let me do it again. What happened there? I don't know. Yeah, here. Linear regression. It's supposed to give me all the things. Somehow it didn't give me the R square. Here it is. Okay. R square in this case is 94%. Okay. Not as good as 99.999% here. So I know the quadratic model is a better fit. How can we evaluate that ourselves? Okay, so remember, first of all, SSE gives you the overall error, okay, sum of squared errors. How can we actually calculate that? Well, it's easy matter now, okay, because we have the result. We can just compare them to the observed version, right? So the observed version is YC, right? And the results, the theoretical results are A matrix multiplied to my unknowns, okay, to my, oops, I have to store that into U first because right now U has nothing in it, okay. So U is my result, which I didn't store into anything, so let me copy that, okay. In fact, let me just copy these three numbers, okay. Store them into something called U, okay. Excuse the slightly different names from those I used in the notes. Okay, so here are my best estimates for those three numbers. Let me actually use that, okay, to compute a bunch of theoretical versions, okay? So that would be given by A times U, right? And those values are to be compared to my Y vector. Let's just take a look at my Y vector here, YC. Okay, well, somewhat different, 6.128, 6.2. So we're going to square those differences and add them up. So there's an easy way to do this using the norm command. The norm command gives us the magnitude of a vector, okay? So it is the vector yc minus a times u, okay? The second part is my theoretical values using my least squares answer. The first part is my experimental values. So I calculate the difference vector, I take the norm, and of course I would like to square that as well. So square it. Okay, so this is the sum of squared errors. Okay. Now, I think if you have taken a course in this before, then you know there's a formula, okay, that we do in order to compute R squared. Namely, it's the sum of squared errors over the sum of the total sum squared sums. Okay, let me explain what that is. Okay, let's say you're doing linear regression only. Okay, so you have a bunch of data and you have a least squares line. Okay, if you naively just look at the mean value of y, okay, which we can call y bar, you may ask yourself, hey, how come all these numbers are different from this y bar? Okay, they change a lot, okay, with respect to y bar. So you can calculate all those changes or discrepancies and square them all up. That would be something called SST, okay? Just not using the model at all. Just look at the y data and compare each to the mean value of y, square each entry and sum them all up. Then you expect to get a larger result, right, than SSE. So if the least squares model actually explains things so well, then you can expect this quantity to be very small compared to this quantity, okay? And it's never going to be larger than the denominator, which you can prove. Okay, I'm not going to prove that. So 1 minus this, hopefully, will be close to 100% if you have a very good model. Okay, excuse me, I have to drink some water. Okay. So how to get this SST? Well, one easy way to get it is just let the calculator compute it. Okay, so you can, for example, if you have put this thing on a spreadsheet, okay, you can do that on the spreadsheet. Okay, and then it doesn't really matter if you do it on the calculator or the spreadsheet, but I'm going to do it here. Go to menu, statistics, stat calculations, and just do some one variable calculations. Just one list, and the list is y, okay? And well, let me show you more here. You see SST does show up in one of its, oops. This one, okay? This one here is the SST, okay? Just look at the definition, okay? It's not really X values we're dealing with here. We're dealing with Y values. You can just right click and variable, store it into a variable. You can store it into SST. Okay, SSY, whatever, okay, SST. Okay, then you can come back. Okay, let me give you back the calculator view. You can come back to 1.1. And so SST has some value. SSE has some value. Oops, what did I call it? Actually, I didn't call it anything, okay. So let me store this result for SSE into a properly named variable, SSE. Okay, so now I can do this. 1 minus SSE over SST, and you get your 99.999%. Okay, So that's a very easy way to do these things that you may have done in statistics or econometrics class in the past. Okay, now let's get back to this uh, linear, no, sorry, not linear regression, but level net problem. Okay, now let's take a look at this level net again, and maybe let's start a new calculator. Let's start a new problem, in fact. Insert a new problem. That's a calculator. Okay, so let's take a look at this problem again. We have three unknowns, B, F, and G. And we have oops, let me start from scratch, okay? So level net problem, we've got three unknown heights for B, F, and G. And what we have done is 6 sets of measurements that gave us experimental values, the 6 numbers that correspond to different linear combinations of B, F, and G, and this number, which is a benchmark value. So for example, the first line tells me B minus 100 was observed to be 9 point something, and the fifth line tells me F minus B was observed to have a value of 9.505. So how can we use all of this data to figure out the best possible value I can get for B, F, and G? So let's think about how we can formulate this in terms of A matrix times U unknown type of problem. Okay, so what is your A matrix here? Well, that's not too difficult, but let me give you a hint. Okay, it would be easier if you treat this as 0 for now. That would make the problem slightly easier to formulate. You could include this 100, but I'm going to kind of take a shortcut and pretend this is at 0. And once I get the values for B, F, and G, which will obviously be too small, 100 too small, I will just add 100 to them. So that's like shifting your coordinate origin to a much higher place for now. So what is really 100, you call that 0 in your new coordinate system. Okay, so I hope that's not too difficult. So let me think about what I have observed. What are the theoretical versions of these numbers? So these numbers, I'm going to call them my y vector. What are the theoretical versions in terms of my unknown? And let me write down my unknown vector now. That's easy. That's just B, F, okay, and G. That's my unknown U, okay? Collectively, it's called the U vector. So what kind of A matrix do I need? Well, a moment's thought should give you the entries of A. In particular, for the first one, it's B, okay, B minus 0 here, okay? So it's just 1 here, no F, no G. So that's B minus 0, okay? And the second entry is what? Well, the second entry is F minus 0. So I need a 1 here to pick up the F, and nothing else to be picked up, no B, no G. The third line says G minus 0, so I need a 1 here, okay? And what else do I need? So fourth line, I have, now be careful here, going from B to G, so that the number that you get tells you what is G minus B. Okay, so G minus B, you need a 1 to pick up the G. You need a minus 1 to pick up the B. You don't need any F, so 0 here. Okay, and what about line number 5? Well, we already said it's F minus B. So the minus 1 here, the 1 to pick up the F, and nothing for G. Okay, we're almost there. Let's just complete it. The last one, we have going from G to F, so it's F minus G. So it's 1 here for F minus a G, so minus 1 here. And no B to be picked up, so 0 here. Okay, so that's your matrix A. In this case, oops, those things disappeared. Too bad. Well, we can just type them in. A matrix. Okay, now this time you are going to actually have to use this particular matrix template. And number of rows is 6. Number of columns is 3. Okay, so I'm not gonna spend too much time on this. I have only 5 minutes left. Okay, let's see if we can quickly recall. Okay, 5 minutes. Let me just try to finish it. Okay, so B minus A. Okay, remember the order B, F, G. So I need a 1 here to pick up the B. Nothing here. Nothing here. Okay, the second line is what? So this is good practice. Okay, F minus 0. Okay, pretending A is at 0. So I need a 1 here, okay, and 0 everywhere else. For the third line, it is G minus A, which is, we pretend that to be 0. So we just need to pick up G with a 1 here. Okay. So unfortunately, we do have to type these in. Unfortunately, they're not too long. Okay, just 1s and minus 1s and 0s. So for the fourth line, it is formed by what? It's G minus B result. Okay, so for the G, I need a 1 and minus 1 to hit the B. Okay, and no F. Okay. And number 5, F minus B. So I know that I need 1 to pick up the F, and B, I need a minus 1 to pick it up as minus, and 0 here. Finally, F minus G. So F is in the second entry, so I put a 1 here, minus G, right? So line number 6, F minus G. So minus 1 here. Nothing in B. Okay, so that's my A. Let's see how much time I have. I have 3 minutes. Okay, very quickly, let me type in the Y vector. Okay, it's 9.131 and so on. So you see the tedious part is just the data entry, okay, which you can actually copy and paste from the PDF if you have the file. Okay. Now, since I'm doing this in a rush, I may have made a typo. Okay. In fact, I should do it. Well, I could have entered in square brackets, which would save me this part. Okay, I need to now convert it. Actually, this is silly. I just forgot to do it as a vector to begin with. Okay, now I need to convert the list to a vector and also transpose the result. Okay, so just let me double check all the numbers are correct. Okay, so now it's a very easy matter to do A transpose times A and invert the whole thing. So take it to the -1 power, multiply to A transpose again, and multiply to, oops, let's, okay, exit the exponentiation space. So we are really multiplying separately to the Y vector, okay. So these are the answers, and of course I need to add 100. This may not work, okay. So it's every entry needs to be added to 100, but it's easy to read off the answer, right? So the first answer is 109.124. The second answer is 118.632. The third answer which is the best coordinate for G, okay, or the height. Best estimated height is 104.330, okay, to 3 decimal places for G, okay. So if you want, you can write it like this. Okay, never mind. You know how to do it, right? Just add 100 to each number, okay. All right, so that is the end of this example. Okay, so I will answer any questions that you may have at this point. Otherwise, you're free to go. I've heard very little from you today. I hope this whole thing didn't go muted. I'm really worried that you never heard anything from me because somehow my microphone's not working. That doesn't seem to be the case because I see a microphone picture on my desktop, and it's going up and down. Okay, so any questions, guys? Just say something so I know you're there. 나가요 뭐에 많아? Nobody wants to say anything?
Professor,
Yes.
could you explain why there is a 100 meter for about the benchmark of A?
Well, I'm trying to make it easier to formulate here, okay? So imagine if we carried this 100 with us. Then, okay, imagine we do the whole thing, okay? So we say it is not B minus 0, but B minus 100 that was observed to be 9 point something. Okay, that's going to be making my formulation a little bit trickier because then I have to take care of this minus 100 somewhere, right? Because my goal is to separate all these, I call them left-hand sides or theoretical versions, as just simply something multiplied to B, F, G. Okay, but that would be more difficult to do if I had to carry this 100 with me. So basically, I'm going to have to flip that 100 to the right-hand side and say, okay, it's going to be 9.131 plus 100. Okay, then I can go back to this and just do my easy matrix 1, 0, 0. Okay, so you're going to have to include a lot of these 100s for all those lines, for example, line number 2 or line number 3, because they all involve this 100. So your right-hand side, you will have more work to do on the right-hand side than just calling it exactly these numbers, okay? Some will have the addition of 100s to them. So that is slightly messy. So that's why I decided to pretend this is at 0. That's not a big issue because if you have a place benchmark A, that's a physical place. You call that 100, I call that 0. It's just like my coordinate systems maybe starts at the top of the Lion Rock, let's say, or some mountain, okay? So what's 100 to you is 0 to me. Okay, so my coordinate system is having its origin located a lot higher than yours, exactly by 100 meters off. So I know my answers for B, F, and G. If I want to translate them back into your coordinate system, I would have to add 100 to my answers. That's all. So if I measure 9 meters in my coordinate system, but I'm already on top of the Lion Rock, so I have to tell you it is 100 plus my 9, so it's 109 for you, okay, working with the, say, Hong Kong principal datum. So that's the only reason, just for some convenience in the formulation so that I don't have to worry about plus 100 because you could make a mistake here, careless mistake. Okay, it should be plus 100, but you did minus 100. So that's tricky, okay, and error prone.
You are
Okay.
of convenience, but what I'm wondering is that Like for A, it is already has a height of 100 meter.
Mm-hmm. Well, remember, A is not an unknown, so it doesn't matter. A is a constant. A is not an unknown, right? It's just a constant number.
Okay, thanks.
Okay. Any other questions? So the only unknowns in here are three, B, F, and G, namely. Okay, there are only three unknowns. Okay, any other questions, please? By the way, this matrix skills will be useful not only for project type 1, but project type 2 as well, because uh, the bridge analysis software will be formulated in terms of a matrix framework. Okay, so let me remind you. Namely, we have a truss bridge, and somehow we're going to translate that into some matrix. Let's call that M times the input forces. Okay, input forces. Let's call that U. Will give you the output forces, which we will call whatever answer A. Let me not use A. Maybe whatever F forces. Okay, for all these forces. Okay. So there is a matrix formulation that makes it possible for you to have an input-output relationship between the loading on the bridge, the loads, you know what loads are, okay, given in U, and the properties of this bridge, which is described by matrix M, and that would allow you to get the output F, which is the forces collectively in all these members. Then if they're negative, you make it red. If it's positive, you make it blue, whatever, and also indicate the numbers. Okay, so there will be some matrix manipulation to do, but I will minimize that work for you by doing it mostly by myself. But at least you need to understand what is happening and somehow transfer all of this work onto your software so that the numbers can be translated into some colors and some graphics. Okay, that will be the main part of the computer science majors project. Or if you're not a computer science major, but you're good at it, okay, and you're interested in this stuff, or you're very good, say, with Excel programming, then also you can feel free to pick the number 2 or type 2 projects. Okay, anyone else with a question? If not, then we'll stop the video so I can. Yeah,
I want to pose a question that's for the advanced analyze the question that's why something we like to say like the line form will be considered as G minus B.
Mm-hmm.
Yes.
Well, that's just the definition, okay? Just I'm giving you these arrows to explain the meaning of these numbers. So any arrow means I go from B to G. So from B to G, you see there's a drop, okay? So from
Yes.
B to G, that's what the arrow tells you. From B to G, it's a negative result. So that must mean G is lower, right? G is lower than
Yes, I
B.
see this. It's an observed increase of elevation go negative.
Yeah, so it's G minus B that I'm observing. That gave me a value of negative 4.7 something. Okay, so if I go from some place to another place, I observe a number. Okay, that must mean it is the second place's height minus the first place height that I'm observing, right? So if G were higher than B, then I would have a positive number here. So it's the second thing minus the first thing, okay? Because I'm going from first to second. Right? Just think of it as a definition, okay? Indicated by the arrows. What minus what. So number 5 must be F minus B, okay? Because I'm going from B to F. Does that answer your question?
So I see that for f minus b equals to positive. So there is the from root 6 is like f
Okay.
minus
G.
g because I
Exactly.
can't see that on the screen
Exactly.
because f minus g because f is higher than g.
Well, not because f is higher than g. It's just the definition of this arrow means you're observing f minus g because you're going from g to f. You're
Okay,
getting a
so
number.
it should be it should be expressed in opposite directions in terms of minus, right?
You don't have to care about whether it's positive or negative here. Even without any number, okay, ignore all these numbers. Number 3 means you are trying to get g minus a.
Yes.
Oops. Number 4 means you're trying to get g minus b. Number 6 means you're getting f minus g. Okay, whatever the result is, doesn't matter if it's a plus or negative. Okay, I don't have to look at these results to tell you what number 6 refers to because this arrow tells me it is f minus g and so on. Okay. All right.
I see. Thanks.
Okay. Anything else? If not, then I will stop the video. Okay. I'll post the link soon. Sorry that at first a couple of minutes didn't get recorded. Okay, so I'll stop the sharing.